Good morning, class, and thank you to Mr. Sloan for covering for you, or for me, even. Can just to start, I know you had homework from yesterday, and I can see that very few of you have uploaded the homework. Can you please make sure that you send me some evidence of that homework? It'll all be taken into account in terms of grades and so on down the line. Now, I'm going to go over the answers to homework tomorrow in the video that I send you for tomorrow's double. Right, so today, the thing I want you to do to just see what you know from yesterday is there's a quiz on Google Classroom, and I want you to do that quiz now. It's going to take a minimum of 5 minutes. All right, so if you go to, let's see, where is it? So if you go down to today's work, okay, so there's a quiz on rusting and redox. If you just click on that and attempt that now, please. Thank you. And if Mr. Sloan wouldn't mind pausing the video while you do that. Thank you. Okay, so what we're going to work on today is two things. You're going to have a test on metals and the reactivity on Friday, and there's also in the rusting, redox and iron section, there's something actually that I moved from the last topic that we didn't get done, which is extracting metals on page 4. So we're going to finish with that, but I just want to talk you through the test on Friday. That will be your homework, right, to study for that test. And I've posted a few resources for you on Google Classroom. So I've posted an Excel, one of those retrieval roulette quizzes that I've been using previously. So I'm just going to come out of this and share that with you. Okay, so I'm going to send you the quiz, or I have it there. It is now, it doesn't work terribly well through Google Classroom. I suggest you open it in Excel, or you can just use the questions directly. You can definitely use that through Microsoft, or sorry, through Google. Okay, so you've the list of questions here, and what you can do is go to Do Now, and you will have 5 random questions. To change the question, just press F9 on your computer. Okay, I'm sure this won't work on the phone, but F9, and then you will get 5 different random questions from the 60. Now focus on your word equations, observations, and the different colors of the different substances that are formed, right, and what you'll observe during reactions. That will come up in the test. There will be balanced chemical equations. So what I'll do is you have the option to write a word equation for 1 mark, or the balanced chemical equation for 2 or 3 marks. So it's where you're at. I have posted videos of how to do word chemical equations. And as I said, you'd better focusing on the word equations at this level, because you'll definitely get a pass. If you know those, the chemical equations can take so long to get to master that it may just not be worth your while. You're better focusing on the base knowledge to get your C or your B. Okay, so that's that, and I put the notes on again as well. Now, there's one thing I want to just draw to your attention that will be on the test, or something like this. So again, I'm just going to change the screen. So this is in your metals and the reactivity notes. It's at the end, right? So questions like this, right, where you're given a table of metal displacement reactions and what happens. Interpreting these it's going to come up on the test, right? It's quite a common exam question. So what you have here is 4 different metals, and you add them to 4 different metal salts, right? And you observe whether a reaction occurs. And if it does, it means that this metal has displaced this one, right? So you can see magnesium has displaced silver here. You don't bother adding a metal to itself, to its own compound. That wouldn't make any sense. Let's say copper does displace silver. And from that, you can deduce which is the most and least reactive. So I'm going to let you have a look at that yourselves. Just be aware here that what you're looking for really is the most ticks. Okay, so whatever metal has reacted the most, right? So here it's magnesium. It's reacted with, here it's magnesium because it's reacted with silver nitrate, copper nitrate, and iron nitrate. So it's definitely the most reactive. And then the least reactive will have the most X's or no reactions. So you can see here silver is the least reactive because it didn't displace magnesium, copper, or iron in their compounds. So it must be right at the bottom of that set of 4 metals in terms of reactivity. And then observations are another thing. It's not mentioning it here, but just remember that if a metal forms, right? All metals are shiny grey at the start and shiny grey at the end, right? If they're produced, unless it's copper, which is red-brown. And assume all solutions are colourless, unless it's copper solutions, which are blue, right? That's the safest thing to do. So just make sure you read through the notes to get that. Okay, so now we're going to go to your notes on the redox, rusting, and iron. So if you could just take a moment maybe to have a look at that screen there while I change and have a think about the answers to that and what you might need to know for that. Okay, so page 4 of your notes. Right, so take a minute or two, just to have a read of what it says on page 4, because the rest is questions. It's a tiny quantity. As I say, this is actually in your metals and reactivity notes, but I'm pretty sure we didn't get this done. Make a bit more sense now that we've done oxidation and reduction. Okay, so you can see here that the idea of metals, right? So you should be familiar with the idea of an ore. We will definitely come across this concept of the ore, the metal ore, right? An ore is a rock that contains enough metal compound in it to be worth extracting. So economically worth extracting. A lot of rocks will contain some metal compounds, but they might be so spread out or so such a small quantity that it would just financially make no sense extracting it. And then some metals are so unreactive that they are found in the element in the Earth's crust. So the metals right at the bottom of the reactivity series that we actually didn't see, copper a bit, but gold, platinum, silver to an extent, those type of really unreactive metals can be just found in pieces and taken from the Earth. So, but most metals have to be extracted from their ore, which is normally a metal oxide. Now, the more reactive a metal is, the harder it is to separate it from its compounds. If you think back to last year in bonding, you will know that the metals have the most reactive metals. Just a moment, unfortunately, this is live and my bell has rung. Okay, so the most reactive metals will need to go through a process of electrolysis, right? Now we won't study that until later in the year. Hopefully we get a chance to do it. All you need to know is it's a process of separating metal compounds back into their elements, and it is a process of reduction, right? It involves a reduction, or well, more specifically, redox. Now, carbon is in brackets here, and if you think about it, carbon's not a metal. So what's it doing there? Well, carbon can be used, or carbon compounds, particularly carbon monoxide, can be used to do a sort of displacement reaction with metal oxides. So anything that's lower than any of the less reactive metals can be extracted by reduction with carbon or carbon monoxide. And we have an example here, which actually don't worry too much about, because actually this is what tomorrow's lesson is going to be about. It's going to be about the extraction of iron from its oxides. Okay, this is actually a simplified version of the reaction. But if you can take a moment, okay, so actually what I want you to do now is complete the questions that follow, which actually are all related to what you've done on oxidation and reduction. So that's what I want you to do for the rest of the class. Thank you.